Okay, this is going to be a quick going over. The question's basically the same question that was in Copeland, but it's an opportunity to play with the equation and write down its various forms. So, starting point for these types of problems is this equation: tan theta equals t minus d over L, okay? Where theta equals angle of ascent and T equals thrust, D equals drag, and L equals lift. So that's your equation. Now you'll see in this question is you've got a lift to drag of 13. So I've circled and underlined the main points, and a thrust to weight ratio of 0.45. Okay, now you'll look at this equation and you'll say, I can see a D and an L, so I could do a reciprocal of that, but I don't have a thrust to weight, okay, in this equation. So you might be saying, well, how can I use this equation? Well, you've got to remember that this equation, for small values of theta, we can say that tan theta is approximately equal to theta, and we can also say that lift is approximately equal to weight, okay, for that small angle, because for a small angle the lift vector is only tilted over a little bit, so your thrust and your weight will be approximately the same value, okay? When we get to that, we can write a new equation, which is theta equals t minus d over weight, okay? So that's handy. And then we could also write it, because we've now got the thrust to weight, which is what we wanted, but we don't have a drag to lift, okay? So, but you know that you can substitute a lift or a weight in the bottom here. So you can rewrite the equation as theta equals thrust over weight, so that's our thrust weight ratio, minus drag over lift, okay? Because those two are approximately equal, okay? The small values of theta. So that's another equation that you can derive from this main equation, okay? So either memorize all these three equations or just remember that step. Small value, we get to that, and we get to that, okay? So now we can just substitute in. We can say theta equals thrust to weight, thrust over weight. Well, our thrust over weight is 0.45. And then we're going to say minus drag to lift ratio. We've got a lift to drag ratio, so if we flip it, we're taking the reciprocal of our lift to drag. So what we need to do is look at our lift to drag and take the reciprocal of it. So 1 divided by something is the reciprocal. We talked about that in the last video. Okay, so then we just grab our calculator and we say 0.45, okay, minus 1 divided by 13, just like that. So we use our fraction button if we want, okay, and then we go equals, and I think I've done that wrong. 0.45 minus 1 divided by 13 equals 0.37. Radians. And then if we change that to degrees, and they might ask for the angle in degrees. If they haven't, you can just express it in radians, but most likely they're going to ask for the angle in degrees. So what you need to do is you need to multiply this value by 57.29, because there is 57.29 degrees in a radian, or you can do it this way. So that's our answer there. You can go hit your shift button and go to your DRG button, which is above the answer button. And when you do that, it gives you this whole series of things. Now Now, it says 1 is degrees, but you actually have to, because it was expressed in radians, you have to hit number 2 and go equals. Okay, so that equals 21.4 degrees. And just to check to make sure that that's actually correct, you can go 0.37 times 57.29, and yes, it's 21. So that is the answer for question 3. Hope that helps.